Hi, this is a recorded lecture for the DP Design Technology topic 3.4 Computer Aided Design. And of course, computer aided design, we shorten that to CAD. It is the use of computers to aid in the design process. This video right here is kind of interesting. It just shows you how parametric design principles are used. It's kind of an interesting video and pretty well done. It's a little old, but still worth a watch. Lots of different types of computer-aided design that we want to talk about. We have 2D, 3D, and then rendering. So in general, 2D design, we're going to be using, at least for us, Adobe Illustrator, but you might also use AutoCAD. We like to use Fusion 360 for 3D design, but you could use SolidWorks or SketchUp, and then rendering, you can use any of these particular CAD programs here. We're going to talk about some of the different types of CAD models that you might produce. So the first one is called a surface model, and we really need to be careful with these definitions and keep them in our minds here. So a surface model is really a photorealistic image of a product. It offers some kind of machining data, but little or no data about what's on the inside of the product. So you can see here this mouse is showing you beautifully rendered surface. It's photorealistic. It looks like the real thing, but we have no idea about what's on the inside. So this is why it's a surface model. So literally, if you think of the skin deep idea, it doesn't go deeper than that. It only shows you the outside and nothing about the inside. Now, when we think about models that do show us what's happening on the inside, we're talking about solid models. I find this to be one of these vocabulary terms that can be a little bit confusing, because when we think of a solid thing, we think of, a sort of homogeneous mass that has little to no differentiation, but that is absolutely not what we're talking about here. So this is showing us the outside and the inside components. So it's really important that you make that distinction. So don't get fooled by the word solid here. It means that we can have clear representations of the final product. It provides a complete set of data for the production, and this is internal and external. So it's really important that you understand the difference between those two. Remember that surface models only show you the outside and nothing about the inside. We have data models. These explicitly determine the structure of data or structured data. Typical data models include databases or information systems. They could be graphs also, or flowcharts, that kind of thing. Developments in information and communication technologies, that's ICT, make data modeling important to applications and use in the exchange of data. Here's an example of some data modeling right here. So, weather data is a huge thing, and you can kind of look at how you represent that. But data modeling is used to determine the structure and display and organization of data. So for instance, weather, temperature, air quality, precipitation, that kind of thing is all represented in this data model right here. It's showing and structuring the data, displaying it, and organizing it so that we can understand it. Virtual prototyping, this is where we have photorealistic CAD-based interactive models that use surface and solid modeling. So this is both surface and solid, so the outside is photorealistic and the inside has everything that you would expect. And they can be considered a digital mock-up. And they're really good for checking if things work, if they're going to, for instance, stack properly, or how they actually can be interacted with. So they're good. I mean, you can't actually interact with them in the sense of physically interacting with them, but you could rotate them, you could take them apart, you could look at how they fit together and assemble. So that's virtual prototyping. These next two vocabulary terms are also a bit confusing, so we got to try to keep them clear in our minds. So bottom-up CAD design. This is a designer creates part geometries independent of the assembly or other components. Okay, so although there are often some design criteria established before modeling the part, this information is not shared between the models. Once all the parts are completed, they're brought together for the first time in assembly. So essentially what you're doing with bottom-up CAD is you're designing all of the pieces. So you can see an example here. You're designing all the pieces separately, and then you're putting them together once you've got them all designed separately. So that's what bottom-up design is. Top-down design is different. So this is a design that is a product development process attained through 3D, parametric, and associative CAD systems. The The main features of this method is that the design originates as a concept and gradually evolves into a complete production consisting of components and sub-assemblies. So I think the major difference between bottom-up and top-down is that with bottom-up, you're designing all the components separately and then bringing them together. With top-down, what you're doing is you're actually designing them as they would be in the design. So you're designing them kind of assembled. You're not assembling them after, you're designing them as you would assemble them. So I think that's the big difference between the two when you're talking bottom up and top down. All right, we can talk about a digital human. So a digital human is a computer simulation of a variety of mechanical and biological aspects of the human body. Digital humans can be used to present joint resistance, discomfort, reach envelopes, and vision fields. They can be used, for example, to measure the impact of clothing on human performance. So you can see here's a digital human in a cockpit, and it would allow you to, you can actually watch this video, and it allows you to see how that person actually can fit into that space. Motion capture is the recording of human or animal movements by any means, for example, by video or magnetic or electromechanical devices. This video is great. It really shows you how you can video capture people, and you use this a lot, motion capture. You use this a lot, of course, in like Hollywood movies. This is Planet of the Apes. And you recognize this guy, maybe he's the one who played Gollum in Lord of the Rings, but he also played Caesar in Planet of the Apes. He's been in a ton of different movies, and he's often done video capture. And so, yeah, watch this video. It's actually quite entertaining and good. So motion capture can reduce the cost of animation, which otherwise requires animators to draw either separate frames or keyframes that are then interpolated. Motion capture saves time and creates more realistic natural movements than the manual animation, but it's limited to motions that are anatomically possible. So you can't really motion capture something that people can't do. Some applications might be animated superheroes, might require additional possible movements, etc., etc. But it's using that motion capture for analyzing how people move. Haptic technology is an emerging technology that interfaces the user via the sense of touch, also known as force feedback technology. So haptic technology works by using mechanical actuators that apply forces to the users. I was actually just listening to a podcast about this, that they were using this to help people hear. So they would have a device on somebody's wrist, basically a bracelet, that would give them some sense of where a sound is coming from. So it would hear a sound and it would allow somebody to actually know where that sound came from, the loudness of the sound, the pitch of the sound, all kinds of different information, and people were actually using this to help them, in a sense, hear. That's haptic technology because it was using pressure, mechanical actuators that applied forces to the user's wrists. So you can simulate the physics of the user's virtual world. It's possible to communicate these forces into real time. Haptic technology allows users to become part of a computer simulation and interact with it, enabling the designer to observe the user's performance and to design a better outcome. It can also be used in simulations where it's difficult to train in a real environment. Haptic technology is also used in feedback devices in home entertainment consoles. So this could be like vibrating and buzzing cell phones and that kind of thing. So, here's an example of a haptic technology suit. You see these in lots of shows and stuff now where people wear kind of a touch suit. We have virtual reality. So this is the ability to simulate a real situation on a screen and interact with it in a near natural way. So, these devices are now coming online where people can actually be strapped into a harness and they can actually move around and interact in a three-dimensional, it feels like a three-dimensional world because you're able to move around with it. Animation is the ability to link graphic screens together in such a way to simulate motion or process. And generally, when we're talking about animation and CAD, we're talking about this, like how would a robot interact, not Daffy Duck and Bugs Bunny. And then this is one of the IB's favorite things to put on test, finite element analysis. And so this involves the calculation and simulation of unknown factors in products using CAD systems. So you can simulate stress on a welded bicycle, like in this example right here. And Fusion 360 does this. It's actually, you have to play with it a little bit, but you can get some really great results where you can see where the stress and the strain on different joints or parts of a particular product are going to occur, and then that helps you plan for that. Here's a video about 2D CAD design, so you can watch that. So it's Illustrator in 5 minutes. That's two-dimensional CAD design, and thank you for watching.